Welcome everyone. We'll get going on time for a change, or close to. I'm Dr. J.D. Armstrong. I'm the Maui Technology, Education, and Outreach Specialist. And so I put together these talks. And today we have Miss Laura Ulibarri. Did I pronounce that close to right?
Yes.
Okay, good. And I've known Laura for a number of years. She got her Master's of Science in Physics at the University of New Mexico. She's currently the director of the Maui High Performance Computing Center. She's the president of the Maui Makers and owner of P and L Maui. And what she'll be talking about is sort of an informal history of AOS, and anyone here who has other little tidbits, I think you're encouraged to contribute those so that we can get a more complete history.
Yeah, and I'll have to correct you. It's not AOS. I'm not going to talk about AOS today.
AOS. You're going to be talking about
pre-AOS.
Pre-AOS. So the Maui Space Surveillance System.
Actually, AMOS.
AMOS.
Yeah,
okay.
So there will be a quiz.
All right. I'll go out and take my notes. All right. Well, thank you for coming, and let's welcome Laura.
So I'm going to start this off with a big disclaimer. So I'm not a historian. I'm talking about things that may have happened or may not have happened before or shortly after I was born. So I'm relying on other people, so this is all stuff I found in the open. So. But the thing I've noticed is that the Air Force that runs the site, they tend to turn over. Military rolls over every couple of years, and so sometimes you tend to lose history at a site. And I think this is a site that's rich in history. I like to kind of understand where things come from. So I spent a little bit of time for fun digging into this. I think that, and I'd like to encourage people, I see some of the old-timers here, and we have a brain trust here that I'd really like us to capture the stories of the site before we lose them, because I think we've already lost a lot of the history, and I'm afraid we're going to lose more. So I'd like to see more people contribute. I think the Air Force is going to do... Okay, I think the Air Force is going to do an official 50-year celebration this year, so hopefully that will spur them to really dig into this history. But I'm going to just show you some fun things I have picked up in terms of looking back, and then I'm going to show you an interesting video of the construction of the site. So, and all the views are my own personal views. I do work for the Air Force, but this is all stuff I gathered from talking to people or in my spare time. And so, nothing official here. So I'm going to talk kind of a theme of satellite tracking and imaging. But we're gonna kind of go back to 1952. So it looks like the Defense Department presence started before 1952, and I really can't quite figure out when it started. So to put this in perspective, so things really seem to have started happening up there around World War II. So the Army was doing something up there during World War II. It had to do with antennas, and I think they were doing aircraft warning, although I haven't been able to find anything about what they were doing up there. So to me, that's kind of an intriguing thing. What was...
Okay.
Are we good? Okay. Okay, so what was happening? So they were doing something up there on Red Hill. I haven't been able to find something. It was Project Blue or something that if you search on the internet, you really don't find much. But they were also down in Pukalani, which is where the Air Force originally set up camp. So But one thing I think they figured out is that you get too many echoes putting a radar up on top of a mountain that's surrounded by water, because usually you want something behind the radar to catch the scatter. And so I don't think they mentioned that to anybody. So there was an amateur astronomer, and Grote Reber, who actually invented radio astronomy. And he worked with the local college, and he built this radio antenna up top. So it operated for a while, took some data. Eventually there was an ice storm that took it out, and my understanding is it didn't work real well because you got too much reflection from the ocean surface. So it points to one reason for looking into history is sometimes we find the same things coming up again, where if we know kind of what other people have done before, maybe we don't have to repeat the same mistakes. But apparently this was good for him. He's well recognized as the father of radio astronomy, and doing it all started apparently out of his garage and went globally. So if you look a little bit before this, 1945, that's when World War II ended, and the big thing that came out of World War II that really started spurring progress at that time, or some of it you may call progress, some of it you may not, was German rocket technology. So the Soviets and the Americans had both captured German rocket technology. And so now we got into the space race and the nuclear weapons race. So people were working on ICBMs. So that really started a lot of push into astronomy. How could astronomy help kind of what was going on with the space race? The other thing that occurred was the International Geophysics Year. So 57, 58, there was this International Geophysics Year. And so to me it was kind of interesting reading about it, because that was the year Sputnik got launched. And so people were telegraphing, the Soviets and the US were telegraphing beforehand that they were going to launch satellites in the International Geophysical Year. So people started getting ready for this. The Smithsonian Astrophysical Observatory started setting up sites worldwide, and there was this trend for amateur satellite watchers. So when the satellites launched, there was this worldwide network of amateur satellite watchers, which I didn't realize. I know we still have amateur satellite watchers today, but there were people watching them and handing off to, and so there was this collection of Baker-Nunn telescopes, and so one of them was put up here on Haleakala. I find this picture interesting because this picture was taken by Ansel Adams. Yeah. So, and if you look at the original structure for it, it didn't look like much, but it was doing some pretty important stuff. So these Baker-Nunns operated for a while and did a lot of interesting stuff. And when the satellites launched, they started watching the satellites. And so that was the first satellite tracking. And so this was done actually by the Smithsonian. And the University of Hawaii, I think, was operating it for the Smithsonian. But around this time, University of Hawaii, some of the researchers there, they started looking at the idea of watching solar flares. And so they came up with this idea of something called a solar flare patrol. And so they started looking at Haleakala as a possible site for that. The other thing that happened was with the Cold War in full steam, the U.S. Defense Department started getting concerned about intercontinental ballistic missiles and nuclear weapons and things like that, and then space and what's going to happen when satellites are flying overhead. So they started looking at initially they started looking at using the site on Haleakala to track missiles being launched from Vandenberg to Kwajalein, so watching missile tests. The interesting thing is it was sponsored by ARPA, so this was the precursor to DARPA. I guess they still were the Defense Department, but they didn't say the D. The D was silent at that point in time. So, but the same people that brought you the internet. So they proposed this infrared facility for watching these missile tests, but they also wanted to have a strong component of IR astronomy in it, infrared astronomy. So they gathered a very prominent panel of astronomers, and they talked to them, and they decided that the southern location of the satellite and the very clear, pristine viewing conditions that people were starting to observe at the site made it a really good candidate for astronomy. And so they came up with this idea for this dual-use observatory. And then it's interesting because then the satellites started getting launched, and then they kind of added satellites back in. And so the site is always, it's gone back and forth a little bit between satellites and missiles, but its original idea really was astronomy and missile launches. So this is taken from an applied optics paper written by Ralph Zirkind, who was working at ARPA. He appears to be the person who was really pushing this project, and it was called Project AMOS. And so we can have some fun with the AMOS and what does it stand for. So I know at this point in time the A stood for ARPA. I think the M stood for mid-course, although I've seen it as mid-course and Maui. And I've seen this in official and unofficial documentation. So there seems to have always been a little bit of a schizophrenia over the name. Okay. Yeah. So there's an observation that maybe some of the confusion is because the original mid-course aspect was classified. But they were saying it was for missile tracking. I mean, there was Physics Today. No, Applied Optics published it was for missile tracking. So it's, I don't know, and I've seen it in internal documents. I've seen it both ways. So it's not clear to me. But so they started planning this site back in, I guess they made the decision to go ahead in '62, and they designed the site in '63. And so this is the artist rendering. It's nice Cold War Defense Department construction you can see there. And then if you look, here's it actually being built. One nice little interesting feature of the building here is they decorated it with lava rock, which I also find it kind of fits that time period in the I guess the Art Deco kind of decoration. So so now I'm going to go into some video of the construction. So I happened across this video, and I haven't seen the video anywhere in any official archives. It just seems to be floating around in the wild. So it's an hour and a half long, so I'm going to spare you an hour and a half, and I'm going to show you what I find the interesting tidbits of this video. one interesting thing is they'll try to show you some panoramas. They'll try to bring in this cultural aspect of what the island was like at the time, which I also find kind of interesting. So we're going to start down in the cane fields here, and we're going to drive up the mountain. And there you can see the signs, and the road really looks like a lot of fun. And we haven't even got to the national park, and it's not even really a 2-lane road. So there's Crater Road. So we're going to turn off, and go up the hill. And so you can see, look at how wide that road is. And we're still not even to the national park yet. So we're still going through that nice ranch land up there. Okay, now we finally get to the park. There's a nice car for you. Yeah. And so now we're getting into the park, and pretty soon here we're going to come across the visitor center, which looks a lot the same. Yeah, and actually the road here looks like it might be a little bit wider up here in the national park than it was down in Pukalani. So here we're arriving at the site, and so we're going to get some nice panoramas. And so not a lot of building there down in Kihei yet. It's a little bit washed out because this is apparently somebody had this VHS. So February 11th, 1964. So that's the groundbreaking for the site. And I'd really like to know who all these people are, because some of them look like they could be pretty important. They're all nicely dressed. There's some military folks you'll see later in the picture, and I'm sure there's probably some politicians. And so, yeah, could be. I don't know. And I like the little microphone they're using there. And then they all have their shovels there looking nice and official. So they chat for some time. I'll spare you all the chatting, because it goes on for a while. Yeah, so I'm curious. I can't find any news articles about this. You'd think this would have showed up in the Maui News. There's some tidbits in the Maui News, but I haven't dug into the Maui News articles. But there's a listing of the Maui News, and you'll see Haleakala pop up quite a bit. So we're going to skip ahead here to a little bit more action happening, because this is a lot of construction, and I'll spare you things until we get to some things to me that looked kind of fun. Here's your safety sign. Safety is important. Now remember that as you watch the rest of the video. So I don't know that OSHA was as active back then. So yeah, they're going to do some panoramas from the top. So the clouds look kind of the same, and so you can see. I think the precursor to the FAA was up there. The Smithsonian telescope was up there. And the crater was up there. And if I had some video editing skills, I would kind of chop out the more interesting parts. And so they're really digging in because they're putting in these, they decided to put in cast iron telescope bases, which was pretty unusual. And it saved them a lot of money, apparently, so I like using the steam shovel as a hammer there. And they, but they really had to get down to anchor this thing. So that's we've upgraded the astronomical facility by then. It's not just in a shed. It looks like it's in a real building with a dome now. And then, so there's actually quite a bit going on up there during that time period. Another shot of the facility with the dome. And so I'm going to go ahead to, and they did learn some things as they were going along with the construction, because here they've found a better way to hammer those into the ground. And then this is the fun part. And that's got to be probably the most miserable job. And you, I don't know if you noticed the safety harness he didn't have on. Yeah, so and then every once in a while you see somebody who must have been important, because he's just standing around pointing. And I'd really like to know who these guys are. There's one of a guy standing around smoking a pipe and pointing, so I know he must be really important. And then here they're pouring the concrete, and this also looks like a pretty miserable job. Thinking about 3D printing with concrete, and then watching these guys pour concrete where they get a tub, swing it over on a crane, dump it out, and then go back for the next load. So this is, 20 years after World War II, and less than a decade after the launch of the first satellite. So yeah, and then you kind of wonder what they were doing with those tubes, but they're anchoring them down, and then they get to fill those up with concrete. Hopefully the guy got out of the tube before they put the concrete in. There's a few areas where you just see, like, it looks like you see like what might be an arm, and you see a dirt coming out of the tube in some of the earlier parts of the video. It's quite an engineering feat for the time, and apparently they were on time and on budget. So you can see how deep those tubes are going down. Because I'm not sure. Dick probably knows how much those telescopes weigh. Do you? A lot. And so if the computer will cooperate, So the computer needs to think. So here they're building the telescope piers. So the way they did it is there's this room underneath, and then they're building up this pier for the telescope to sit on. There's another one of those really important guys who gets to stand around and tell everybody what to do. So you can see all the structure for building up those. There's going to be 2 telescopes in this facility. And then we're moving to September of 1964. And so we get some nice angle shots of what's happening on there. So that's a wide angle looking back to where they're building. Getting in close, it's actually starting to look like a building now. And that yeah, so you can see that bottom part of the telescope pier is starting to get built up. And then at the end, we're going to get some more local color. Once they've shown us some of this, we're going to head down the mountain. So they've got some nice concrete slabs going there. So you can see there's a sign showing you where the astronomical observatories. University of Michigan was the folks building this. So they, yeah, and here they're pouring some more concrete in the dome, so bigger crane. And I'm waiting for the local color to come in. I didn't think it was quite this long. There we go. So here's the cane workers. Or pineapple workers. Yeah. Cattle. Yeah, and I think I managed to skip over, so now we're in October 64. I think I managed to skip over the cane truck, but the cane trucks still look pretty much the same. So now we're moving into November, and it's starting to look like a building. And you can see the second pier is starting to get built there. And now you're starting to see the interesting architectural feature where things come out and you get that overhang. And then we have some more wide shots. So there's a wide shot of the building, so you can see the 2 places where they're going to, the 2 telescope domes. To some idea of, now we moved into January of 65. And so it looks like the building part is pretty much finished, but we've still got to finish these telescopes on the side. And the construction of the domes on the telescopes are kind of interesting. So you can see there's one of the domes going up. And so now we're into February. And we're starting to get some structure on the domes. One thing that these domes, a lot of effort into these, but these didn't work real well. So this was the one part of the project that didn't work. For tracking of satellites, they needed to be able to move much faster than tracking astronomical objects, and they didn't design those properly. So they had to go back and get with the astronomers and have them figure out a new design for these domes. So my understanding is that caused some significant delays in opening up initially. So you can see it's starting to look like a telescope. One of them, it looks to me like they built there's a 1.6 meter and a 1.2 meter. It looks like they built the 1.6 meter first. You can see the nice safety harnesses the guys are wearing. Yeah, and building these domes in place, so quite an interesting feat up there. You can see the dome starting to come together, and then we move ahead. If you would like to move ahead. So it just doesn't want to give me that one part of the video that I want. So there's a dome coming together. You'll notice he's got his safety on as well. So yeah, there's lots of video of these guys just crawling all over the place. Little rock climbers, but nothing that looks like a safety harness in sight. And then things are going to get exciting here because the equipment is going to start showing up. So they're doing some nice sciencey stuff up there. So there you can see we've got two domes. Things are starting to look pretty good. Starting to get some power in. Got some more important people standing in front of the building. These may be the construction company that made the telescope. Be interesting. It'd be kind of interesting to find some of the guys who worked on this and talk to them, but no idea who that might be. So now we've got the barge coming in, and this is an important barge because it's got the telescope parts on it. So you think astronomy is a lot of this sciencey stuff. But there's a lot of high quality construction goes into making these things work. We're in 65, early 65. So I think we were up to February 65. so yeah, they're driving it off the barge. And that's the first time, when this off, that's the first time we see the AMOS name. So they have Project AMOS on the side of the container. And then, so they're starting to build cranes to lift the telescope mounts in. Remember, these things are solid cast steel, or cast iron. You know if it's iron or steel? And they're going to have to lift these things up and put them in and attach them to bolts in the floor. So the Century Detroit was the company that made these. And the weather this day doesn't look all that good. Yeah. So first they've got to unload these from the truck, which is a chore in and of itself. Then they've got to unpack these things. And then they've got to lift these things up and drop them inside and get them on exactly the right set of bolts on the floor. And then we've got some more parts that we've got to take out of the box. So, to Project AMOS, University of Michigan, in Pukalani. So there's an address in Pukalani. It's a savings and loan. So then we've got the base of the telescope, the mounts holding the optics in them. Those also have to be lifted up and put in place. And then, so now we're to August of, and we've got to bring up the next telescope. So we've got to erect a crane, a scaffolding, that thing up. It looked to me like they use the same one. They're far enough in time that, and they look exactly the same. But the video has no sound on it. So they have to erect another crane. And then they have to bring the rest of the telescopes up that road. I'm guessing the road was probably closed. And I look at the wheels on that truck. That's not the wheels you see on semis nowadays. And he can't even keep both sets of tires on the road there. And he's just creeping up the hill there. Yay, he made it. Yeah. So then we've got to take the second crane, unload it from the truck, and pick it up and put it in. So that's some nice heavy lifting. So yeah, it's going to the savings and loan, University of Michigan. It is savings and loan. Yeah. Yeah. So I haven't looked up yet. Well, 738 Punene. So I'm betting that doesn't even exist now. Well, probably Punene now. Yeah. Okay. So here's another telescope assembly. So they've got to again put this on that nice bolt on the floor. Yeah. And so you can see here they've got this holds the optics. So they've got it inside the dome, and so now they're going to have to lift that up and attach it to the base there. So it looks to me like they built the 1.6 meter first, and then they built the 1.2 meter. So this one has two assemblies on it. So you saw the one on the right, and then they've got to put the other one on the left side, and then they've got to get that thing balanced. Tell us how hard that was to balance, Richard. Yeah, so the comment from one of the experts in the room here is that the bearings were hydraulic and they appear to have been over designed because they kept loading it up with weight, and it just turned up the pressure and things kept working. Yeah, I did read that the bearings were built to pretty tight tolerances. Okay, so somebody just looked up the address and it appears to now be First Hawaiian Bank, so it's still a bank. Yeah. Yeah, so there's some discussion about University of Michigan having an office there. So, and then, so they brush up a few things and call it done. And yes, it does snow on Haleakala. Yeah. Yeah, so it's near the end of the year. I don't have the exact time frame, but it might be November, December. You have to look through the video. They put little timelines in there. Sometimes you can read the times, and sometimes you can't. But it's somewhere near the end of 1965. So they're giving you the nice panorama. You can see they've got the lava rock glued to the front of the building. The building appears to like it might have windows at the time, which it doesn't now. It doesn't have that overhang. That lava rock facade is long gone. Entryway is completely different now. Things don't look quite the same up there in terms of the other structures as well. But the National Park Service observatory still looks the same if you look in the video. And the photographer tries to get artistic every once in a while. You know, there's the footprints in the snow, and so. But I think it's because of the issues they had with the domes. It actually took them a couple of years after this to get it operational. So they weren't really 1967. So. Yeah, and IFA has a lot of good information on their website about the Baker Nun, but I haven't seen anything on the IFA website that shows that the building with the dome on it, so I'm a little bit curious about that one. So
I'll check into it for you.
Yeah, so, but yeah, I was hoping that, you know, this would kind of get people thinking about, you know, what's happened on top of Haleakala. And we've got some folks, Richard Poley and Don. Yeah, this is, before, but 69 is a lot closer than. Yeah. They want you on the mic because they're recording for posterity.
Came in '67 as the infrared guru.
It's
and I was just a general physicist. My first task was to get a mount model calculating the gravitational deflection, because we had a 2 arc-second pointing requirement. That's blind pointing, and that means the model has to correct all of the flexures. And I found a few. There was a model. I found a few different currents.
Yeah, but it looks to me like it. So is it true that 67 through 69 is that kind of 67 when it went operational, Don, or?
Well, I came out in March of '68, actually.
Okay.
And I was brought out as a young junior engineer.
Uh-huh.
I was working at the University of Michigan at the time, doing infrared work, mostly with missiles, tracking missiles. Anyway, the fact that I knew the word infrared, they said, okay, you can go to Hawaii, because they had the 1.6 and the 1.2 in particular was there was radiometers on one mount, and then the tracking tracker, the infrared tracker.
Yeah.
What I was working on. Back then there was some. Anyway, there was, like I said, a lot of firsts. Track missile finally.
Yeah.
Richard and John Brown, who was a computer guy.
Yeah.
Paul McCormick, of course, he was our leader.
Yeah.
The first job of note I remember as a very junior PhD was to come out and hold a picture of the moonscape in front of the CRTs, because we knew where the few corners were on the moon.
Uh-huh.
So we adjusted that So, and we knew where we were bore sighted. So I had to hold the picture there while they moved the picture in, and Dr. Paul McCormick was shooting his ruby laser, trying to get a return, because when they took off, they're afraid of dust that might cover the cube corners. Anyway, he blew the ends off his ruby, and no one ever did get it until 3 months later, but not that night. So that was that Apollo mission that put the cube corners on the moon. That was my first job.
Yeah, and so there's, I mean, there like these guys said, there were a lot of firsts out here that were first ever. And one thing that's kind of unfortunate about the history at the time is I think it was really highly classified, because one thing that folks were working on that was first ever operational out here was adaptive optics. And so the first operational adaptive optic system was on the 1.6 meter telescope out here. And that was all done in high secrecy. It was the compensated imaging system, I guess jokingly called the classified imaging system. And so it was all done under the Defense Department. And then the idea for Laser Guide Star was actually they were shooting, as Dr. Poley mentioned, they had some lasers that they were shooting, and so they were shooting a laser and they were imaging with the compensated imaging system. And one of the guys looked up and said, "Hey, I could use that laser when it's scattering off the atmosphere. I could use that as an artificial star." And so then folks started working on the guide star technology. And so when all this adaptive optics, they decided to release it to the world. There's a really good book written by the Air Force. So that part they did do well, is capture the story of the adaptive optics revolution by Duffner. So they captured that part of the story pretty well, but a lot of the story, I think, at the site here seems to be missing. And so that's why I kind of like guys like these who can tell you the real story of what was going on at the site, because it's got a pretty rich history that really I don't think gets enough recognition in the global community, because all the IFA folks here could tell you how important adaptive optics is to the astronomers. And I was reading, Bob Fugate was one of the folks involved, and his legacy really is the guide star laser part of it. And but he was talking about, so it was all funded again by ARPA, DARPA, and because they liked high risk, high payoff things. And his comment was the astronomers weren't looking at it because it was too risky. And DARPA said, we'll give it a try because it's risky, and if we can do it, it's going to revolutionize things. And so it's a pretty incredible technology, and it was built right up the hill here. So these guys are my heroes.
I just want to say one more thing. When I first came here, and during the construction too, there was no place for offices on Maui. We had a small office upstairs of Kabibi Liquor Store, and on Vineyard Street. And we traveled from there to the top, but that's where most of the engineers stayed. And then later, we moved into the Pukalani Hospital, the old Pukalani Hospital, which is on Hansonville. And we were there for several years. And that was a major upgrade, but now we have, Premier Place and all those nice buildings up here. So,
yeah. Yeah, I heard the first supercomputer was in the nursery. Yeah.
Anyway,
Yeah, yeah.
They came out in 1969. In 1975, Lockheed Missiles lost the contract. So I went back to the Palo Alto Research Lab where they were working on space-based lasers. Came back 10 years later as kind of an expert in beam control. But during that time, I remember about 1980, they were talking about this Project Lodestar. Now, the adaptive optics system was being used by Lincoln.
MIT Lincoln Labs?
Who? No, it was. No, it was. There was a corporation out here doing it, and I've forgotten what the name is. No, it was Lincoln Lab, I guess it was, someplace in Massachusetts. Sally Raisback worked for it.
Yeah, Lincoln Labs.
Okay, and they were doing adaptive optics. They were using stars.
Yeah.
And trying to get the stars. So the guide star concept was new around, that was an addition, and that was new around 1980 because I remember being sworn in on this ultra secret project called Lodestar, and it was highly mathematical, and you didn't want to let it out, but that was the original name.
Yeah.
And then that was accomplished with the sodium laser, and then they, after they'd proven it, they brought it out here, and now it's on almost every decent telescope.
Yeah.
All over, but so it was first adaptive optics, and then it was the guide star.
Yeah.
Concept.
Okay. Thanks. So what? Okay.
Offered you the job when you were just graduating. You had a choice of going to 3M or Maui.
Oh, well, see, I was buddies with McCormick in graduate school, and I should have beat him out, but he came here 2 years ahead of me, and his expertise was ruby lasers, and he used to get returns off noctilucent clouds, 1 photon or 2 photons. He was counting photons. So he got enough prestige, so when I was out graduated finally, he offered me a job, and at that time I had a choice between Maui and 3M in Minnesota. So it was really clear. And at that time, we were making about 2/3 of what a full professor in the University of Hawaii, and we had COLA,
Yeah.
15% on top of that. So it was a no-brainer. I came out here.
Yeah.
When you get to 1985 and talk about the BDT and the relay mirror, I'd be happy to comment then, because all of those concepts were really space-based laser concepts. I was the chief engineer in the space-based laser, not the relay, but all of those were discussed.
Yeah. Yeah. Well, you're going to talk to us about that, aren't you? You're going to be the one telling us about that, aren't you? Okay. Well, let's give a round of thanks to our old timers here. So that's all I had. So. No. Yeah, I'm not sure we want that one on YouTube. Yeah. Okay. So thanks everybody, and yeah, if folks are interested, we can probably dig some more in the history here. Yeah.